continuing with the Unit 5 study guide. Okay, so it says if f of x equals 3 times 1/4 to the x, find the correct range values. So basically what they're telling me is the range is when I work it out. So I'm going to plug in a -2 right here, plug in a -1, plug in a 0, plug in a -2, and see what they equal. Okay, so here we go. We're going to say, first one I'll do 3 to the 1/4 to the -2. Okay. And how that works is that power gets put on both of those. So it's 3 to the 1 to the -2 all over 4 to the -2. And remember, if I have negative powers, they have to flip. And so this turns out to be 3 times 16. It goes to the top and then becomes a positive power, and I square it. So 4 squared is 16. So that's 48. Okay, that's my first one. Then I'm going to go ahead and plug in a -1. So that's 3 times 1 to the -1 and 4 to the -1. That flips to become 3 times 4, and that's 12. I'm going to plug in a 0. Remember, anything to the 0 power is 1, so it's only on this, so this is just 3. Okay? And then that's a repeat. So, looking at these, my correct ranges are 48, 12, and 3. So it says, what solutions can be modeled by exponential functions? So basically, we're looking for things that increase as you go farther and farther into a process. You increase by a lot or decrease by a lot. So if you look, say he's paid $15 an hour. No matter what, he always gets $15. You're not going to see substantial growth in that. Simple interest kind of acts like it, and usually I would accept something like that, but we talk about it. But the big thing we're looking for is compound interest. Compound interest is when you get interest on top of the interest you already received, and the money starts to grow faster, especially after a long period of time. Okay. Let's see here, and so like I said, I would also take that one. Andrew drained his pool at a rate of 5 gallons per minute. That's going to remain constant. Steve collection of insects is doubling every month. So at first it's going to start kind of slow, but this will eventually get really big. Okay, that's exponential as well. All right, choose all the following that are situations that could be modeled. So looking at this, if the number, if I have an equation, okay, and whatever the x is on, if that is bigger than 1, this is going to grow in this direction, okay? So these two are possibles, okay? The number decreases. If this was decreasing, okay, this would be going in this direction right here, and it's not. 3/4 of the plants die every season, so I would take A or C on that. How can you determine if a function is exponential growth or exponential decay? That's what I was just talking about. So if I had a function like f of x equals 4 to the 0.8 to the x, and I had another one like f of x equals 4 to the 1.8 to the x, okay, so the value that has the exponent, if this is less than 1, it's decay. If this is bigger than 1, this is growth. So now we're going to simplify here. Okay. So remember, all the negative powers have to switch. So this 3 to the second comes down. This c to the second comes up. This a to the 0 is just a 1, so that goes away. And b to the 8 just stays up top. That's just a regular power. Then I'll simplify a little bit, and I'll say, probably should write these in alphabetical order. B to the 8th, c squared all over 9. 17, how do we solve? This is a big thing that we do, and we alluded to this in a lot of other questions earlier on, but you got to remember that whenever you solve an exponential, and that means the variable's up in the power, the only way to do it is to make the bases the same. So like if I had something like this, right, 2 to the x equals 2 to the 3, well, since they're both on a 2, the 3 and the x equal each other. So I got to make this thing a base of 2. So what I can do here is I rewrite this one, and 8 is the same thing as 2 to the 3. Okay, kind of erase this, get this out of the way. 2 to the 3, so that says, well, since they're both on a 2, these two equal each other. So I'll add a 3 to both sides, and the x equals 6. Okay, you need to know all your bases and your powers to be able to kind of spot those numbers. Alright, so it says consider the function y equals 25 times 0.2 to the x. Find the range for each given domain. So same thing, I have to plug them all in and work this out. And this is one I could probably just enter in my calculator, but I want to write them out. So if I have 25 times 0.2 to the negative 2, I got to do 25 times 0.02 to the negative 1, so I did that one and that one. 25 times 0.2 to the 0, and 25 times 0.02 to the 1, and coming down here, 25 times 0.2 to the second. Okay. So now when I enter these into my calculator, okay, I'll say 25 times, I'm going to put this in parentheses, 0.2 to the negative 2. Okay. That comes out to 625. Okay. Now if I continue plugging those into my calculator, this is what I get. Okay. And then they ask me, as the value of the domain increases, do the values of the range increase or decrease? So look, so I plugged in a so these domains are right here, the things I plugged in. So I plugged in a negative 2, a negative 1, 0, 1, and 2. Those are getting bigger. Okay, so negative 1 is bigger than negative 2, 0 is bigger than 1, 1 is bigger than 0. So as the things that I plugged in, the x values got bigger, what happened to the y values? And that's what I got when I solved. See, here's my y's. So as my x's got bigger, you can see my y's got smaller, so they decrease. Okay, they decrease. All right. So let's go ahead and look at next one. So what they're saying here is you borrow $7,000 at 2.5% annual interest. How much will you owe after 3 years if it's compounded yearly, it's compounded quarterly, compounded monthly? So we'll give you the formula when you do this. You just be able to plug it in. And so the formula works like this. So what you do is it's the amount, or A equals the initial amount, so it's 7,000, okay? And then it's 1 plus, and then it's the interest rate, and as a decimal, so in this case it's 0.025, so I got to move that 2 places, sorry, going this way, all over the number of times per year it's compounded, and it's compounded yearly, so that's only 1 time, okay, to the number of times that it's compounded, which goes right here, times the time, which in this case is 3 years. So what I'm going to do is I'm going to kind of set all these up. And show you so you can see what remains the same and what doesn't. So in this case it's compounded quarterly. So if you were to break the year into quarters, that's every 3 months. Okay, sorry, every 4 months. 3 month is a quarter, I meant to say. So it's at 4 times. So it's quarterly. So it's compounded like this. And if it's compounded monthly, that would be 12 times. And they'll give you the formula on the test. You just have to know what everything is. So up here is the interest rate. This is how many times it's compounded. This is for how long you let it compound for. So this is going to be a 12. Okay. So same thing here. You've got to learn how to enter this stuff into your calculator. So what I'm going to go ahead and do here is, should I do that? So we're going to say, okay, so I'm going to do inside the parentheses first. So I'm going to do 1 plus, I'm actually going to do the second one so you can see how I entered it into the calculator. 1 plus, first let's do this, 0.0025 divided by 4. So I divided the fraction, and then I'm going to add that to 1. Okay, so I get that, 1.00625. Okay. Now that all is going to be raised to a power of 12. I got to multiply those two, so I'm going to do my little caret to 12, and that's what it equals, 1.077. Okay. Then I multiply that by 7,000, and that's how much I'll have. Let me double check and make sure I did that right. 1 plus 0.025 divided by 4 raised to the 12th, yeah, that was right, times 7,000. Yeah, there we go. I think I entered it wrong the first time. There you go. So that's 7,543.43 cents. Okay. And if I repeat that process, I'll get this for this one. Okay. Now this one up here, let's do it by hand a little bit. We'll kind of write it down as we do it. So the first thing I'm going to do is I'm going to add these two together. So that gives me, kind of writing a little bit smaller because I know I got to fit this in. 1 plus 0.025 to the 3. Okay, I'm going to add those two together, and that's going to be 1.025 to the 3. Now I'm going to put that in my calculator. So I did the same steps. I'm just doing it more on a calculator now. I mean, on a piece of paper as well as the calculator. Equals that times 7,000, and that's 7538.34. So those are our answers right there. So you can see here, the more it compounds, the more money you get. So it's just a little bit more, but it does all add up in the end. Okay.